forming on the foil and the color of the solution also fades. A clean aluminum foil that is dipped in copper sulfate solution, you will observe that a brown layer forming on the foil and the color of the solution, this blue color solution, fades. Now the question for team D is, why did the brown layer appears on the aluminum foil after it was dipped in the copper sulfate solution?
Ma'am, copper sulfate depletes a layer of copper on the aluminium.
Reason behind it.
What is the reason? Passes to team A.
Ma'am, the copper sulfate reacts with the aluminum foil and forms rust.
That is not rust. Team C. Actually, this reaction is
We are having separate.
anyone from the audience? Yes, come closer.
I am Rudra from class 8A and this is because of the positive and negative charges, the attractions of copper to aluminum.
Yes or no?
Actually, this is due to displacement reaction. Aluminium is more reactive than copper. That's why that ground cover layer will be formed on that aluminium foil. Okay, we are moving ahead. Next activity is for team A. Okay, in our next activity, come on, let's make the spiral paper dance. Spiral paper cutout is hung on the stand. When the candle is kept near the base of the stand, just see what happened when the candle will flame. The flame will come out, the candle. Yes, what you have seen, that the paper cutout started moving. Now you have to tell the phenomenon involved in the rotational motion of this paper cutout. Yes, teammate?
Combustion,
No.
radiation.
No. Passes to team C.
Ma'am, it's because the hot air rises up, so it's rotating.
I'm asking about the phenomenon. You have to name the phenomenon involved here. Team D. The phenomenon is convection. In convection, heat moves through air as the hotter part rises and the cooler part occupies the space at the bottom. We are having a magnesium ribbon which is burned, and you all can see white flame. Now, you can see the white bright flame and white powder formed afterwards. The ashes are white in color. See in your, a little water is added. to this powder to prepare an oxide solution. Just see on this, we are having white powder of that burnt magnesium rebel. Now ma'am will be adding a bit of water. Yes. Now this oxide solution is ready. Now just you have to observe what happened when the red and blue litmus paper is dipped into it. Observe the color change for your question. Just see first how the paper, red and blue paper changes. Ma'am is having red litmus paper, red color paper in her hand.
Okay.
Just observe the color change. Now the question is, why did the magnesium oxide solution turns red litmus paper blue while the blue litmus paper remain blue?
Because the solution made from that ash is basic in nature.
Yes. Very good. Children, you are seeing here two matchsticks. One is used up and the other one is as it is. When these two will be brought closer to a magnet, we see that the burnt matchstick gets stuck to the magnet, whereas the other one doesn't, showing the attraction towards the magnet.
Find the region.
These two matchsticks, just see, team C. The two different matchstick, one is used up and the one we are seeing, which is as it is. And you are seeing the attraction. Okay, the question is for team C. What is the reason for this attraction shown by the matchstick, the burnt matchstick?
Because its property has loosened.
The burned matchstick becomes a temporary magnet.
Now there is phosphorus on the top of the matchstick, and when it's formed, then magnetism is formed.
Phosphorus, no.
having higher radiation than the one which is not used.
Anyone from the audience side? Yes, come. Quickly come forward.
But when the matchstick burns, the iron particles reflect to it.
Yes. Actually, children, the matchstick which is burned, that will attract a magnet because of the burning process creates pure iron metal. But whereas the unused one is having the iron oxide, which will be very negligible magnetic property. The reason behind this is that. He can give because he has given the answer that the iron particles will be there.
My name is Shreya Soni from class 6C.
Second one has a colorless liquid and the third contains vinegar. First, lime water. Second, colorless solution, and the third one, vinegar. Now observe what happened when lime water is poured into the colorless liquid. Yes, you have seen that when the lime water is poured into this colorless liquid, the mixture turns pink almost instantly. Again, when the vinegar from the third flask is added to the same flask, the pink color fades and the solution becomes colorless again. Observe minutely these changes, especially the color of the appearance of pink color. You all have seen? What are the three solutions in the conical flask is clear to you all? Now, identify the chemical substance or the indicator caused the colorless solution to turn pink when lime water was added.
It's phenolphthalein.
Very good.
That indicator is phenolphthalein. Slowly come upstairs, introduce yourself and get your appreciation from principal sir.
My name is Sriti Devi. I am a student of class 7C.
So thank you all. Hope you all have enjoyed this round of scientific temperament. Keep this always high.